Alright, what's going on everyone? My name is Kevin Libwit and this is the second video of a three-part tutorial series on external applications for the CLC Genomics server platform. In the first video of this series, I introduced my three-step approach for writing external applications, and we walked through each step in detail to create an external app for the ivar trim command. And so in this video, we're going to be walking through those same steps to write another external application, this time for MAFFT, a very popular multiple sequence alignment program written by Kazutaka Kato at Osaka University in Japan. And so just as a reminder, here are the three steps that I take to writing these external applications. First is the installation of the tool on the CLC Genomics server environment. Second step is writing a shell script to wrap the tool into a single and static executable. And the third step is the configuration of the external application using the CLC Genomics server web interface. And so with that brief little intro, let's jump into it. Alright, so the first step to writing this MAFFT external application is the installation of MAFFT onto our genomics server environment. And just like in our first video, I have on my screen a terminal with sudo access on the right and the server web interface here on the left. And I am logged in with an admin account. So now that we have this, let's full screen the terminal so we can get into the installation of MAFFT. And just like with ivar, I'm going to go ahead and use Singularity to pull the staff-b Docker image for the installation of MAFFT. In taking a look here at the staff-b Docker hub, we can see two different MAFFT Docker images available. For our external app, we'll be using MAFFT version 7.475. And so I've already got Singularity installed here on my environment, and I can again go ahead and verify that by just running Singularity with that H flag to ensure that I can get that help menu pop up on the screen to standard out. And now I'm going to go ahead and navigate to that Singularity image directory we created for ivar under the ops directory. And then I'm going to build this MAFFT image. So I'm going to use sudo singularity build. I'm going to call this MAFFT 7.475.singularity image. I got to specify that it is a Docker image, and then go ahead and use that staff-b MAFFT image tag 7.475, and this should only take a second to build, and boom. And now we can check to make sure that we can run this container with Singularity to execute MAFFT without root privileges. So here you can see that our image did build in our Singularity images directory as specified. And so let's go ahead and check the functionality. So again, the command is singularity exec. And then we're going to specify the image we want our container to be built upon, and in this case it is that MAFFT 7.475 Singularity image from the staff-b Docker image, and then the command we want it to execute. So for testing purposes, we can just execute MAFFT with the H help flag to ensure we have appropriate functionality. All right, perfect. So now we've got MAFFT on our environment, and we've ensured that it could be executed without root privileges. Step one is complete. And now the next step is to write a shell script to wrap MAFFT into a single and static executable. To get into this, let's start by defining exactly what command our workbench users will execute when using this external application. So for this example, here is how I want my workbench users interacting with MAFFT. So when users pull up the MAFFT external app from their genomics server GUI, this is the command they'll be executing under the hood. So this first bit here is, again, our singularity exec command to run a container based on the staff B MAFFT image that we just built. And this second half indicates the MAFFT command. So this auto flag here indicating that we'd like MAFFT to automatically select an alignment algorithm based on our input data size. The threads flag here with a -1 also indicates an automatic selection, this time for the thread number allocated per step. And then this is followed by the input multi-FASTA file for the actual alignment. And then we want to write this all to a MAFFT_MSA.FASTA file. All right, so to give Workbench users access to this command as a Workbench tool and to make the external app configuration process as straightforward as possible, let's wrap this into a simple shell script that the server can execute. Okay, so first we can navigate to the external apps directory that we created for Ivar. And then let's start writing our MAFFT_CLC.sh script. All right, and just like with the Ivar wrapper, the first thing I'm going to want here is a small shebang statement to make sure that this is executed as a shell script. And then I'm going to define the two positional user input variables, the first of which being MAFFT input. So this is the multi-FASTA input file. And again, this just being the first positional argument. And then the second is going to be the expected output file name and path. So in this case, we'll call this MAFFT output, and that will be the second positional argument. Again, following in line with what we did with Ivar, we're going to go ahead and capture the temporary directory name and then change to that directory to ensure that Singularity is run from that temporary directory upon execution of the external app. So let's go ahead and comment this out. So change to CLC Genomics Server External Application Temp Directory. Well, keep that cap there. And then so temp directory is going to be captured from dir name and that input second positional argument there from the user. And then we can change to the temp directory and we should be good from there. So again, we'll provide a small standard out helpful statement to our users. Oops, server external application. This is MAFFT v7.475. All right, and then the next part is the MAFFT executable itself. So executable. All right, so we need that singularity exec. Then define the singularity image. Singularity images MAFFT 7.475.singularity image, and then the command itself. So again, it's MAFFT with the auto flag with the thread set to -1, and then the input multi-FASTA input, again first positional argument, and then we're going to go ahead and write that to the MAFFT output variable, which is of course the user's second positional argument. And again, this is the base of this simple wrapper script, but again, I like to write a little check script here to make sure that we have created the file that we think we're going to create. All right, so let's do a little if statement. So again, if this file doesn't exist, and this file being the MAFFT output file, then we can let the user know that the MAFFT output was not created, and we'll go ahead and exit with exit code 1, close that if statement. All right, and so that is the entirety of the wrapper script. So just walking through this really quickly, there are two positional arguments, the first of which indicating the user's multi-FASTA input file that will be aligned with MAFFT. The second positional argument being the expected output file to be produced. And then we change to that temporary directory to ensure that Singularity is run where we want Singularity to be run. And then after that, we have the MAFFT executable itself using Singularity to run a container based off of that staffb Docker image, and then just a little sanity check here to make sure that the file is created, and if not, this could be very useful for troubleshooting moving forward. All right, and once you save that script to your external apps directory, don't forget also to add executable permissions to ensure all your users can access this using that external apps toolset. Perfect. Now step 2 is complete. All right, so the third and final step to creating this MAFFT external application is the configuration. And of course, this is done using the Genomics Server web application that I have pulled up here. And you need to be logged in as an admin user to complete this task. So from this admin page, we can again go to external applications. I, of course, already have my MAFFT application here, but I'm going to go ahead and open up a new configuration to walk you through the same process that I did to make mine. All right, so for the application name, I'm going to go ahead and call it MAFFT version 7.475. And in the command line, we're going to go ahead and input that the shell script with the two positional arguments, the first of which being the multi-FASTA input, and then the second of which defining the anticipated output file. So let's first indicate that we want the MAFFT_clc.sh command being executed, and then the first positional argument is a multi-FASTA input file, and then that should populate right under there under general configuration as it did right there. And then the second one is a MAFFT output file, and of course that one populated just underneath. Okay, so for the first argument, this is going to be user selected input data, and this should be a FASTA file. Perfect. And the second positional argument should be the output file that's generated, and this should be an alignment file also in FASTA format. All right, so FASTA alignment, and we are going to call this MAFFT msa.fasta in accordance to the shell script that we wrote just a second ago. And a tool like MAFFT, when you have these standard importers, this is how straightforward it can be. There's nothing else you need to do to configure this tool. So long as you get this, you should be good and ready for functionality. In addition to this, though, I also like ensuring that I have the standard out written to a plain text file just like that, and then also not stopping on execution. Not stopping the execution if there's any errors, but instead pushing all the way through and allowing me to troubleshoot from there. All right, with that, you can just save your application, and step 3 is complete. All right, now that configuration is complete, I wanted to finish this video by showing you what it's going to look like for your genomics workbench users on the GUI side of things. So you can see here now that under external applications, I've got the MAFFT v7.475 external app, and if I open that up, it is a CLC server application, and the single user input is, as we defined during configuration, is that multi-FASTA input. So on my environment here, just for test purposes, I concatenated a number of SARS-CoV-2 assemblies for this example, and I'm going to select that as our input, and then just select this output directory and let that run. All right, so now MAFFT is complete, and you can see that our output directory that we specified is populated with an export log file of the multi-FASTA that we sent to the genomic server for analysis. We also have that standard output text file that we requested upon configuration, just a nice little simple text there. And then here is our multiple sequence alignment generated from our newly created MAFFT External application. So thank you for watching this video. If you have any questions, again, please feel free to leave comments below and we will address those that we can. And hopefully after watching this, you have an even stronger grasp of my process for writing these external applications. I've got one more video lined up where I'm going to walk through the same steps to write an external application for RAX ML. I will see you guys there.